Ready, Brea? Here we go. The Atwood machine is a pulley system, as seen in the picture below, or if you look up, sorry for those of you on YouTube, you can see my little toy here, where when one mass accelerates down, the other mass accelerates up. Like yesterday, we're not going to let you jerk on the rope or yank the rope. The acceleration has to be smooth, which, Danica, means that the magnitude of each acceleration will be the same. If one mass is accelerating up at 2.5 meters per second squared, the other mass is accelerating down at 2.5 meters per second squared. This second mass is often called a counterweight. It makes it easier for a person or a motor to lift mass 1. Here's our first thought puzzle. It says this: equal masses are placed on both sides of the Atwood machine, and one mass is lifted higher, like in this picture. When released, how does the system move? You got 3 options. Option A, the system remains at rest, nothing happens. Option B, the higher mass falls. Option C, the higher mass goes higher. So I have here my Atwood machine. Oh, for an Atwood machine, we're assuming that this pulley that I'm tapping at the top here has no mass and is frictionless, which means it's a magic pulley that doesn't exist in real life. Oh, and we're also, Garrett, assuming that the ropes have no mass, because if I do this, now I've got more mass on this rope, and that would be a changing mass. And you can deal with that with calculus, but we don't have calculus. So we're kind of in our magic physics world, George, where everything just works out nice, right? So if I raise one mass, which mass did I raise? The one on the right. If I lift this mass up, and if there's no friction in this pulley, and I let go of this mass, what's going to happen? Let's vote. So option 1 is nothing happens. Who says nothing happens? 1, 2, 3, 4, 5, 6, 7, 8. Who says, no, the higher mass is going to fall down? Gravity. 1. Who says, no, when you let it go, the higher mass is going to go higher? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. George, did you vote for this one? Because you're usually the outsider. You, sorry? What were you before? You were C? So you'd like to go from that to that? All right. Normally I say convince me, but I think we can figure this one out, because you know what this is a good job for? It's a good job for a free body diagram. I'm going to zoom in on this second diagram here, where it says lift 1. What are the forces on this one here? Get the obvious one. So I'm going to call that mg. What else? Tension, because there's a rope. Is there a normal force? Is it sitting on a surface? No. What are the forces over here? Get the obvious one. I could call it m2g, but are both masses the same? You know what? I'm going to call them both mg's and tension. Now, it looks like most people picked option C. They said the higher mass goes higher. So I guess you're saying that the winner is right here, because that's what would make the higher mass go higher. So let's write an equation, and we'll call anything that ends up pointing down once it gets to the right side winner plus. We'll call anything that ends up pointing up once it gets to the right side loser minus. What will our equation be? Well, let's walk along the rope. I would have mg minus tension. This tension here, Xavier, you might be tempted to say it's also a minus because it's pointing up, but if you follow it, I think when it gets to this side, which way is it actually pointing? Winner plus. This mg, you might be tempted to say it's pointing down like this one, it's winner plus. But again, Brea, if you follow it, when it gets to this side, I think it's pointing up loser minus. That equals M all A. Oh, Sarah, why am I stretching? I love it when I lose tension. Ah! Why am I panicking? I'm not just losing tension. What else am I losing? Well, if everything cancels, what's left behind as a number exactly? I get this. I have something times something equals 0. Well, if you go something times something equals 0, it means one of these had to be a 0. Is the math 0? What must be 0? Hey, what do those 3 dots mean? Therefore, there's an old joke, but it's also true. Anytime you see a therefore, make sure you know what it's there for, because it means some kind of a conclusion, right? What's the correct answer? A, B, or C? That's the only one where you have no acceleration. I'll zoom out in a second. It says explain your answers using principles of physics. That, I did it right there because I wanted it next to the diagram so you could see it on one page. But if you wrote that, I'd give you full props. You could also make up numbers and crunch the numbers, but here, we did one fully algebraically. Everything canceled, A must be 0. If they're not equal masses, the heavier mass will accelerate down, the lighter mass will accelerate up. Yeah. This is why we said we're not including the mass. Our rope is massless, our pulley is massless, and there's no friction. But yes, otherwise, especially instead of rope, what if it was like big steel cable, like the kind they use to support a bridge? Oh, heck yeah. Then it plays a role. By the way, though, this is really nice. What this really means is, for an elevator, there's always a counterweight, the same mass as an empty car. So all an elevator is actually lifting up and down is the mass of the rope. Cable. In diagram 2, it says, assume M2 is 5.8, M1 is 2.3. Solve for the acceleration, find the tension in the cord. We did these in Physics 11. There's probably going to be an Atwood machine in your future in Physics 12 too, because they're nice conceptual questions. Any suggestions on how I might want to start? Darn right. Zach, what are the forces acting on M1? Get the obvious one. I'll call that M1. G. What else? Yep. What about on M2? Not quite. It's going to be M2G, not M1G, Captain Obvious, and tension. Is there a normal force? Nope, there's clearly a gap between the floor and M1, so no normal force. Who's winning? Zach, which mass is heavier? So I might make a little note. A is that way. I might draw that off to the side so I know that's which way we're accelerating, which means anything that ends up pointing down on the right-hand side is going to be winner plus. Anything that ends up pointing up once it gets to the right-hand side is going to be loser minus. Zach, what's my equation? I'm going to put the tensions in my notes. If you don't bother writing them in your homework, I won't freak out. But it's sad, but I'm such a stupid fan of the stretching, relaxing, losing tension joke, Zach. I just have to put it in because it gives me the giggles. Because, Zach, why am I stretching? Losing tension, right? Zach, what did A want me to find? So, how? Yep. A is going to be M2G minus M1G all over M1 plus M2. If this was a quiz or a test, I would now show all the numbers. I would show what I plugged in. Zach, is this a quiz or a test? Let's try going straight to our calculator. Oh, built-in error check. If I cut this rope right there, what's the maximum the acceleration could be if I cut the rope? 9.8. The other mass is slowing us down. I know I better get an answer less than 9.8. If I don't, I've made a typo. M2, 5.8 times 9.8 minus 2.3 times 9.8 divided by 2.3 plus 5.8. Look for typos, Mr. Dewick. That looks good. Do you get 4.2, 3, 4, 5, 6, 7? That's weird. Sorry, my math nerd heart just went dark. 2, 3, 4, 5, 6, 7, 8, 9. Why does it go to 9 and skip the 8? Because it clearly then does 10 and 11. I don't know. I need to dive into that fraction. That just seems like a kind of weird number. But anyways, 4.23. I noticed these weird things on my calculator, Brea. Sorry. 4.23. Am I wrong? Is it 4.23? Yep. Okay. Unit, Zach? Acceleration is technically a vector. I won't ask you for the direction because it depends. Which mass are you talking about, Mr. Dewick? It's both up and down. Which mass do you want me to look at? So we're really finding the magnitude of the acceleration. Danica, what's B want me to find? Like you're feeling right now? Why can't I use this equation to find tension? Yeah, I would make some terribly horrible pun or joke and you can just laugh and think it's funny. Okay, which one do you want to use to find tension? Pick. To be honest, it doesn't matter. It'll work for either one. In fact, I'm going to draw a line down the middle of the page and do both just this once to let you know. I could use M1. Which way is M1 accelerating? Up or down? Which way is the winning force going to be pointing? Same answer. So which force is pointing up in M1? My equation would be tension minus M1G equals M1A. How would I get the T by itself? Yep. Or, Paige, I could look at mass 2. Which way is mass 2 accelerating? Up or down? Which way is the winning direction? Up or down? Which force is winning in mass 2? M2G minus tension equals M2A. How would I get the T by itself? Swappy dance, I think, yeah? Just for fun, how about... Oh, that's wrong, Mr. Dewick. No, that's right. How about this half of the class? Do that equation, go straight to your calculator right now, plug in the numbers. This half of the class, do this equation. Let's see if we get exactly the same answer. So I'll do the blue equation. It's going to be M2. What was M2, Mr. Dewick? 5.8. 5.8 times 9.8 minus 5.8 times... I'm going to use my answer button. Oop, almost made a typo, Mr. Dewick. And no matter which method you use, did you all get 32.3? Danica, you can make an argument, I guess, that was technically a tiny bit easier to get this T by itself because T was the winner, but I'm doing it all in my head in 2 steps, so honestly, I don't care much. As long as you can get tension equals 32.3 newtons from either one. This method that I've given you of who's winning, who's losing, Braden, believe it or not, it's pretty flexible. We're about to jump into a couple of questions you haven't seen before, but I think we can just puzzle it out by using Newton's laws and not panicking. Example 3 says, consider the following system. Which of the following is the best free body diagram for mass M2? M2. Okay. Hey, is there more than one answer to choose from, Mud? Let's vote! How high you hold your hand up, so sure you are. The answer. So, the free body diagram for mass M2, which of these is the best one? Who says, I think A is Mr. Dewick. A. Got 1. Oh, I got 2. Okay. Now it's B. Clearly B. Got 1, 2, 3, 4, 5, 6, 7, 8. Danica, was this a vote yes or just a... Okay. Yeah, I see hand twitches out of the corner of my eyes. Like, is that a vote? Is that a question, or are you getting ready to vote? C. 1, 2, 3, 4. Oh, some of you didn't. 5. You didn't see mu equals 0? Really? First thing I would have looked for. Hey, people. I think it's on ice. Let's try again. Who says A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Who says B? 1, 2, 3. Who says C? Hey, how about we do the free body diagram? What are the forces acting on M1? Get the obvious one. So I definitely have that. Why did you start with M1? Because I think if I figure out M1, that'll help me with M2. I definitely have on M1 an F applied. I'll put a little APP underneath the F right there. What else? Well, is M1 pushing on M2? Forces come in. So M2 is... There's another force right there. I'm going to call that the contact force. I'll call it F-con. I don't know. Something. That's the free body diagram, I think, on mass 1. What are the forces Oh, I heard Darwin. Let's keep going. What are the forces acting on mass 2? Darwin, get the obvious one. Yeah. Yeah. What else? Is F applied touching M2? Okay. What else? What did I call that? I think they're the same size. This is a Newton's third law. Forces come in pairs. I think that's it. What's the correct answer? A, B, or C? Yeah, A. C would be if somehow F applied was reaching all the way through the M1 and hitting M2. It's not. It's not. What's causing M2 to accelerate is M1 pushing into what's causing M1 to accelerate is the contact force, although also M2 is causing M1 to slow down a little bit, but the contact force is almost certainly winning. Sorry, the F applied is almost certainly winning. I said contact force, F applied. It says explain your answer using relevant principles of physics. Yeah, free body diagram. That's good principles of physics. I'm good with that. Ooh, example 4. Find the acceleration and then find the contact force between the two blocks. You know what this is a good job for? Free body diagram. Although, did they give me a picture? I'm going to label the picture. Hey, Brea, is there friction in this question? Nope. Hey, Brea, zoom out. Which way is this whole system going to accelerate? To the left or to the right? And how do we know? The 42.5 is... So I've just decided I'm going to do a free body diagram, but you know which way winner is? To the right. Losers to the left. Where Aiden sits. That's the that came out wrong. Miss you, Aiden. Hopefully you're watching on YouTube and just got insulted via long distance. So let's do our free body diagram. What are the forces acting on the 6 Bray? I get the obvious one. I'll call it M1G since there's more than one mass. Definitely a normal force number 1. I kind of have 2 applied forces, so I'll call this FAP1. Or you could call it FAP-L for left side and FAP-R for right side. Something that works for you. I'll go FAP1 because it's acting on mass 1. Friction? No. Is that all of them? Nope. Which one am I missing? Because if the 6 is pushing on the 8.25, the 8.25 forces come in pairs. I also have a contact force. What about on the 8.25? Gravity. Normal force number 2. F applied number 2. And which way is the contact force acting on the 8.25? I think to the right. Brea, which way did you say is winning? Who's winning? F applied number 1. Winner. And then I guess minus F con plus F con minus F applied number 2. That equals M all A. Mr. Duke, what about M1G and M2G? Are they along this horizontal? Nope. They don't go in this equation. Hey, much like the tensions, the contact forces cancel. In fact, I think A is going to be 42.5 take away 6.75 all divided by 6 plus 8.25. Brackets around the top. So I've never done one like this with you before, but I'm going to argue I think we can do this. Nothing really new here technically, just don't panic. Don't panic. I get 2.508, I'll call it 2.51, but I'll throw this on my calculator. Is that right? Good. Oh, and what's the second thing they want me to find? Okay. Oh, an individual force? I'm going to look at an individual mass. Can't look at all of them because contact cancels out. Which mass do you want to use? M2? Give me an equation. Equals M2A. I guess F con is going to be M2A plus F applied number 2. It's going to be M2 8.25. A, I'm going to write 2.51, but you all know I'm going to use my answer button. Plus 6.75. Yeah, F con. Sorry for the messy writing, Mud. 8.25 times, answer button, plus 6.75. I get 27.4. And you would have got the same thing looking at the other mass. 27.4. Oh, units. It's a force. Newtons. Okay. A curling rock, rock number 1, is traveling east across a sheet of frictionless ice. May as well do a compass rose, can't hurt. It bumps another rock and experiences a force that acts briefly to the north. What will the path be of the first rock after the bump? Path A, path B, path C, or path D? Hey, George, is there more than one option? I think we should vote. How high we hold our hand up is how sure we are of the answer. So, is that a question? Or are you getting ready to vote?
No, I didn't believe that.
Oh, okay. Well, that probably starts. So, rock 1 moving to the right, it bumps rock 2. Rock 2 applies a force due north. After the collision, after the bump, what path does the rock 1 follow? Who says A, Mr. Duick? It's got to be A. That's really, really easy because it gets bumped due north. So A. B, Mr. Duke, is going to keep going a straight line at steady speed. B. 1. C. D. -1. Just letting you know. The -1. That's you. Convince me. Is the mob right? Or do we have our proud, lone, intrepid opinion? Convince me. Yep. Which one are you defending? D? Is there a force going to the right? If we did what are the forces acting on this? Get the obvious one. Gravity would be into the page. Yes. Normal force out of the page. Friction. Are we on ice? So no friction. Yeah. Would the mass of the rocks depend on which one it is? No. The mass of the rocks might depend on how pronounced things were, but not the shape. I had to say that very vaguely to avoid giving away the answer. After the rocks collide and rock 1 moves off, are there any more forces acting on it? So it can't move in a curve, because that would require it to change its direction, which means you're changing your velocity, which means there must be an unbalanced force. So, after the collision, it is going to get deflected north. This is where answering your question. If this was a really, really big, heavy rock, and this was really, really small, it might get deflected like that, or maybe even almost due north. But I'm telling you, I'm pretty sure it's going to be that, right? After the collision, it's going to keep going in a straight line at steady speed. What was your question? Oh, I hate it when that happens. Or maybe you're lying and it's a good lie to cover up your... That's okay. No. You're looking at rock 2. Oh. Example 6. A water bottle is drilled with many small holes so that it leaks when filled. If we fill the water bottle up and then we drop it, what happens as it falls? A, the water stops leaking out. B, the water leaks out at the same rate. C, the water leaks out slower. D, the water leaks out faster. Oh, that was a good physics sigh of contentment. Your brain is being stimulated right now. You know what? I want you to put a tiny little star next to the one you think is correct. Because we're going to do this experiment. The correct answer. Okay. Why? Braden, what did you say? we can look at it a couple of ways. We look at it in terms of forces. Look at it in terms of actually kinematics. I might be tempted to say something like this. So here's the bottle. Here's the water. When I drop them both, what's VI for both of them? What are they both going to accelerate at? Did I drop them both at the same time because the water was inside the bottle? I'm just going to say T equals the same for both of them. Well, look, if VI and A and T are the same, is there any way that D can ever be different for I? They're going to stay together. The water can't get ahead of or behind the bottle. Therefore, D equals the same for both. Okay. What about on the way up? Oh, well, when I threw them, did they both have the same initial velocity? Yeah, not zero, but the same. Same acceleration. They're slowing down at negative 9.8. They both left at the same time. Same D. It's really the same question, just a different VI. If you want to be so kind as to turn in your homework, please, to number 1, and you can answer that question now. If the bottle is now filled and thrown upwards, what will happen? A, B, C, or D? Everybody? Also A. Okay? So now you can skip number 1 in your homework because we did the experiment. One more. Example 7. We'll finish with this. Ooh. Karen, what does example 7 want me to find? Karen, sorry. Yep. A missing mass question. I like this question. I like this question. I like this question. There's absolutely going to be a missing mass question in your future. Well, I'm still going to start with a free body diagram. Karen, what are the forces acting on M1? Get the obvious one. What else? What about M2? Gravity, tension. I have to tell you two more pieces of information. To do a missing mass question, I either have to give you the magnitude of acceleration or tension. Here I gave you acceleration. And I have to tell you the direction of acceleration. Karen, which way is M2 accelerating? I'm going to make a little note here. A is that way. Okay? I can't go winner minus loser equals M all because I don't know mass 1, and if I don't know tension, there's a good chance I might have 2 unknowns. It's yucky. Instead, I'm going to reverse things. When I have a missing mass, I write an equation for the mass that I do know. Which mass do I know? Write an equation for that. Because I know A, I want T as well, and I can find T from the mass that I do know. Swappy dance to get the T by itself. M2G minus M2A equals tension. Tension is going to be 8.4 times 9.8 minus 8.4 times 3.5. $52.92. Is this what they asked me to find, Paige? I won't round this off. I'll carry every sig fig that I can. Good. Taryn, not Karen, but Taryn. Now let's write an equation for mystery mass number 1. Which way is mystery mass number 1 accelerating, Taryn, my angel? Who's winning? Minus? Equals? Yeah. What am I trying to find, Karen? How many M1s do I have in this equation? How many would I prefer? Yuck. You know what? Let's get them to the same side. I'll plus the M1G over. Taryn, how many M1s do I have? How many would I prefer? You know what would be really cool? It would be so cool if there was a Math 9 operation that I could pull out of my back pocket and somehow make this equation go from 2 M1s into 1 M1. There is. Which one? Paige, you remember? Which factoring? GCF. Greatest common factor. Is there an M1 in both terms? Hey, Taryn, how many M1s do I have now? How would I get the M1 by itself? What will I do with the bracket? Oh. Are you telling me that M1 is going to be tension divided by A plus G? Yep. You'll know you've done this right. You'll get either tension divided by A plus G or tension divided by G minus A or something like that. It'll be a plus or a minus. I don't memorize it. I just derive it because I can do it in about 20 seconds. What was tension? 52.92 divided by A. What was A? 3.5 plus 9.8. And I can tell you exactly how big mystery mass is. I get 3.98 kilograms. Sometimes you won't get 2 M1s. Sometimes you only have 1 M1. Oh, even easier to get the M1 or the M2 by itself. But if you have 2, that's a great trick. Who did Pre-Calc 12 last semester? Logarithms. If you had this, you want to solve for x? How many x's do I have? 2. How many do I prefer? You could rewrite it as how would you get the x by itself? Divide by the bracket, and you're done. I saw some students converting all this to decimals and converting all this to... Ugh! Don't need to. Who's in Pre-Calc 12 this semester? I just gave you a preview of coming attractions. Really, really handy way to get the x by itself. Factor it out. Factor it out. Also, those of you in calculus, that'll probably come in handy along the way too. Hey, what's your homework? Oh, from that ultimate review, you're now capable of doing any question that doesn't have an angle or a ramp. No, anything with a theta, walk away. But anything else, you can do if you want to get a head start. And I know some of you do. Hey, we already did number 1. Yay! Number 2, take a look at the second, I guess 2B. I didn't label it as B. What's the left-hand mass? 3m. What's the right-hand mass? M. You can do this purely algebraically, and you'll find you do get an answer somewhere along the way. The m's will cancel. Or if it really makes you scared, let big M be a number. 2. Then it's 6 kilograms and 2 kilograms. Or let it be 5. Then it's 15 kilograms and 5 kilograms. You get the same answer no matter what. So 2 is good. Ooh! 3 is good. You can handle it. Skip 4. 5 is good. Skip 6. 7 is good. Ooh. Is the 5 kilogram mass at number 8 sitting on a table? On a surface? Hey, there's going to be a normal force in your equation as well. Oh, in fact, that's what it wants you to get by itself. Cool. Number 9, if you're looking for a really nasty challenge. Number 9. I'll talk about number 9 in a second. But 10 is good. Here's a missing mass question. I'm going to skip 11 as much as I like it. Number 9 says this. Mass 2 is 12.5 kilograms. Mass 1 is 3.6 kilograms. Both masses are initially at rest, 3.2 meters above the ground. If mass 2 is released, what is the maximum height that mass 1 will reach? Now, you might be tempted to say, well, Duick, if they're 3.2 meters above the ground, isn't the answer going to be 6.4? No. Watch when I actually do the experiment. I'm going to do it on the chair over here. Watch this mass. You see what happened? It kept going up for a while on its own in free fall. Oh, I will get grand total. See if you can figure it out. It's actually all physics 11, but you really got to break it down to its constituent parts. I'm not going to ask you one as tough as number 9 on your test, but if you're looking for a good intellectual challenge, and I'll put out a solution key on YouTube in a couple of days and send out a link if you're really stuck on it. That brings us to the end of review of forces. Tomorrow, Physics 12 forces starts.